These notes are for calculus. It's finding the derivative using the product rule. So up to this point, we've not had to deal with two things that are multiplied together and find the derivative. If we did, we'd multiply them first and then find the derivative. But now we're looking at the derivative with respect to x of a function of x multiplied by another function of x. This is going to equal the first function, so f of x multiplied by the derivative of g of x, plus the function g of x multiplied by the derivative of the first function, f prime of x. It doesn't matter the order that you multiply these in because this is addition, but this is just what has always been done and what I tend to do. So if I have these two functions, f of x is 2x minus 7 and g of x is x squared plus 3x, and I wanted to find the derivative, let's do it this way. With respect to x of f of x times g of x. That means I want to take the first function times the derivative of the second plus the second function times the derivative of the first. So my first function is 2x minus 7. The derivative of the second function is going to be 2x plus 3. Then I'm going to take the second function, this x squared plus 3x, and multiply it by the derivative of the first function. So I'm going to multiply it by 2. From there, it's just a lot of cleaning up. So 2x multiplied by 2x is going to be 4x squared plus 6x minus 14x minus 21 plus 2x squared plus 6x. I'm going to combine like terms, so I have 6x squared, and I'm just going to do this to keep track of everything. Then I have a positive 6x and a negative 14x, which gives me negative 8x. Negative 8x plus 6x will give me negative 2x. I can get rid of all those. And the only other term left is a constant, so negative 21. So this is my derivative. And just so you don't forget, the derivative is the slope of a line tangent to a graph at a point. So if I were to multiply these two together, and I can do that to show you, let's get a different color and I'll show you what I mean. Let's say I didn't want to use the product rule. Let's go ahead and just multiply 2x minus 7 and x squared plus 3x. So I'm going to get 2x cubed plus 6x squared minus 7x squared minus 21x. I'm going to combine these like terms, so I get 2x cubed minus x squared minus 21x. So this is f of x times g of x. Now if I take the derivative of this, the derivative with respect to x of f of x times g of x, power rule, 3 times 2, 6x squared minus 2x minus 21. So it works. So if you have a very simple polynomial equations like this and you prefer to multiply them together, you can. But sometimes you cannot do that. Sometimes you have to use product rule. So here's another example. I want to take these two and find the derivative of them. I could multiply them together, but I'm going to demonstrate the product rule. So the derivative of y with respect to x, the first multiplied by the derivative of the second, plus the second function times the derivative of the first. I'm going to go ahead and clean these up. I'm going to distribute, so I get 30x minus 12 plus 30x plus 35. Combine like terms. 30 plus 30 gives me 60x. Negative 12 plus 35 gives me plus 23. And I'm not going to check this that way. There's different ways I can check it. Okay, this next one, it's got a little bit more going on with it, but that's okay. We're just going to go slow and I'll be careful. So I want to find the derivative of h of x. Well, h of x has got the product of two functions. So the derivative h prime of x is going to be the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. And I'm getting dangerously close, so I'm going to go ahead and do this so I don't run these together. Clean this up. I get 12x minus 8x squared. Multiply these together, I get 15 minus 20x plus 12x minus 16x squared. Start combining like terms. I'm going to look at my x squareds first. So I have a negative 8 and a negative 16. That gives me negative 24x squared. Combine my x's. I have a 12x and a negative 20 gives me negative 8. Negative 8 plus 12 gives me plus 4x. So I can get rid of the x's. And the only thing I have left is this positive 15. That's where it ends. This one, same thing, it's just got some longer terms. So I'm going to be very careful. I think I'm going to run out of room, but I'll get as close as I can. So dy dx, so I have the first times the derivative of the second plus the second times the derivative of the first. I can't believe I fit that all in there. Hopefully you can read it. Now I'm going to start multiplying everything out, and I'll show you a way that I tend to do this. I've got 6x squared times 5x to the fourth is going to give me 30x to the sixth. So yeah, let's do it. I'll just keep going and we'll combine everything, and I'll just be very careful. 6x squared times 2 would be 12x squared. Then I have negative 3x multiplied by 5 is negative 15x to the fifth. Negative 3x times 2 is negative 6x. 8 times 5 is 40x to the fourth. 8 times 2 is 32. That's just this first part. Now I've got to go ahead and multiply all this together. So x to the fifth times 12x is going to give me 12x to the sixth. I'm going to put it right under this x to the sixth here. X to the fifth times negative 3 is negative 3x to the fifth. I don't have an x to the fifth here. I'm just going to go ahead and write it here. 2x multiplied by 12x is going to be plus 24x squared. (2x times negative 3 is negative 6x. Negative 1 times 12 is negative 12x. Negative 1 multiplied by negative 3 would be a positive 3. Sometimes I try to line these all up in order so I could just add straight down. There was too much going on here. I wasn't able to do it. So now I'm going to clean everything up. So all my x to the sixths. This should be my only one right here. Nope, there's more. Thought I had another one. Oh, it's right here. Yeah, 30 and 12. So those two were gone. It's 42x to the sixth. Now I'm going to look for all my x to the fifths. So negative 3 thought I had another one. I do. Where did it go? Well, x to the fifth times negative 3 is negative 3x to the fifth. And then negative 3x times 5x is 15. Aha, I made a mistake there. 15x to the fifth. This is why I did it once before I did here. This is a fifth. You probably caught it and said something. I didn't hear a word you said. So negative 15 x to the fifth. I was thinking I had another one, but I might not. Okay, so negative 15, negative 18 x to the fifth. If you've caught my mistake, if I've made a mistake and I've caught it, go ahead and correct it on your notes. Then I'm looking for my x to the fourths. So I have a 40 here. And that's the only one I see. So this is going to be plus 40 x to the fourth. I'll show you a neat way I can check this in a minute. Then I've got x cubes. I don't see any x cubes, so now I'm going to go to x squareds. Let's go back to blue. So x squareds, I have a positive 12, a positive 24, so that makes it a positive 36x squared. And that's the only one I see, so positive 36x squared. This really does get tedious, doesn't it? Then I've got a negative 6x, a negative 6x, negative 12, and negative 12 is negative 24x. And a positive 32 and a positive 3 gives me positive 35. Now that's different from the answer that I got when I practiced this. So I want to see if I have this right or not. So I'm going to get my calculator. I know, let's say I want to take the derivative of this at x equals, let's try dy dx at x equals 2. I'm going to use this function here. So I've got math down to number 8, the derivative. Oh, you can't see what I'm doing. Let me put it over here. I want d dx, and I need to put extra parentheses, so 6x squared minus 3x plus 8, and then x to the fifth plus 2x minus 1. Okay, I'm just going to go back and double check that I've got everything typed in correctly. 6x squared minus 3x plus 8, x to the fifth plus 2x minus 1. And there's other ways to do this. I know there's many different ways. I'm going to put a 2 in there. Now this is going to be the slope of the line tangent to this function when x equals 2. And I'm just going to write down 2867.003. Now I'm going to do the same thing with this next one. So I want to go to math. I want to do the derivative, d dx. 42x to the sixth. Oops, wait. This is going to be 2, but I want to go back in here. 42x raised to the 6th power minus 18x raised to the 5th power plus 40x raised to the 4th power plus 36x squared. Oops, I got out of that too fast. Minus 24x plus 35. Nope, I did do it. This is wrong. So the answer I got before, and I'm going to check that one, and then I'll just cross this off and write the correct answer. I've made the mistake back here, and I don't want to waste time going back and looking. So the one I got before, I'm just going to go up here and change it. I got 42x to the 6th, so that I got the same. I have minus 6x to the 5th. So I'm going to change it to a 6. And then I have plus 34x to the 4th plus 24x squared minus 18x and then plus 19. Nope, that's not right either. Okay, I have got it wrong. I will grab another piece of paper, and I don't want to waste your time doing it. I'll grab another piece of paper, and when I scan, well, maybe we'll do it in class, or you can check my error, but I'll get the right answer. I just don't want to waste the time going back over it over and over again. Let's do a couple more examples. This 2x minus 5 squared. Right now I'm going to teach you how to do it with a product rule. Later on I'll teach you how to do it with a chain rule. What this means is f of x is going to be 2x minus 5 multiplied by 2x minus 5. So the derivative is going to be the first multiplied by the derivative of the second plus the second multiplied by the derivative of the first. Clean it up. 4x minus 10 plus 4x minus 10, 8x minus 20. Here's another one. This one has got a lot going on with it. You could do it one of many ways. There's three things going on. You could do a product rule within a product rule. I tend to start losing what I'm doing. So the way I did this one, I took these two and multiplied them together first. So I got y is equal to 6x squared minus 21x plus 2x minus 7, and then x squared minus 9. Combine my middle terms, I get y equals 6x squared minus 19x minus 7, and then x squared minus 9. Then I'm going to do my derivative. So y prime is, I've got the first times the derivative of the second plus the second times the derivative of the first. I'm going to multiply everything together. I've got y prime equals 12x cubed minus 38x squared minus 14x. Then I've got x squared times 12x, so that's going to be 12x cubed. This is where I'm going to go ahead and put the 12x cubed right below. I've got place values. It's going to be easier. I'm not going linear. Then I've got x squared times negative 19 gives me negative 19x squared. Negative 9 multiplied by 21 gives me negative 108x. And negative 9 multiplied by positive 19 is going to give me a positive 171. I like doing it this way because then I just add straight down. So 12 plus 12 is 24x cubed. Negative 38 and a negative 19 gives me negative 57x squared. Negative 14 and negative 108 gives me negative 122x plus 171. We also do these with trig. So with trig, it's still the same process. This is saying you've got this function sine of x, and I'm going to multiply it by this cosine of x. So I want to do the product rule. I want to take the first, multiply by the derivative of the second, plus the second, multiplied by the derivative of the first. So sine of x multiplied by negative sine x is going to give me negative sine squared of x. Cosine x multiplied cosine x is going to give me positive cosine squared x. You can leave it like that. A lot of times people like to switch it around so it's cosine squared minus sine squared. And be careful, this is not the Pythagorean identity. Pythagorean identity would be sine squared, positive sine squared, plus positive cosine squared equals 1. So I'm going to stop there. So I've chosen number 6 because it's very much like number 3. I'm saying this is sine squared x. It's like this one here. This was 2x minus 5 squared. The function was 2x minus 5. My function here is sine x. This is saying sine x multiplied by sine x. So when I do the derivative of this, the first times the derivative of the second plus the second times the derivative of the first. So I have sine x, cosine x, sine x, cosine x. That means I have 2 of them. So just to go along with this, this is where this stops. But there's a pattern that starts to go here, and I'm going to get you thinking about this pattern. So if I want to extend this a little bit. So say I had y equals sine cubed x. Well, that's saying y is equal to sine squared x multiplied by sine x. So I'd have the first times the derivative of the second plus the second times the derivative of the first. Well, I said the derivative of sine squared x is this 2 sine x cosine x. So I've got y is equal to sine squared x cosine x. Oh, I have a sine x here and a sine x here, so this is going to be plus 2 sine squared x cosine x. So I have 1 sine squared x cosine x and 2 sine squared x cosine x. So this is going to be 3 sine squared x cosine x. What if I want to do sine to the 4th x or sine to the 5th x? There's a pattern here. And in this pattern, I will teach you later on how to use it for using the chain rule. Now, just out of curiosity, you can stop the video there. I want to see if I can find my mistake with that other problem. So I'm just going to grab a sheet of paper and go slower. But you are welcome to stop here and not worry about it anymore. So I have lines. I'm going to go slower and be careful. Okay, so this is the third time I've done this one. Third different answer I've gotten. Yeah, it's third different. Let's try this one now. I think I still have that in there. So 42 x is 6 minus 18x to the 5th. Plus 40 x to the 4th plus 36 x squared minus 24x plus 19. 8024. Nope, I still don't have it. I have no idea what I'm doing wrong. Not going to waste your time.